Now listen, using these arguments, there is a important relation or important result. So you can prove that this J0 square plus 2 into J1 square plus J2 square plus etc. equals 1. This is an interesting result. We know that d by dx of jn square plus jn plus 1 whole square is 2 into n by x jn square minus n plus 1 by x jn plus 1 square. By using that result, we can immediately show that j0 square plus 2 into j1 square plus j2 square plus etc. equals 1. How? So consider this relation. Mark it as star. So in star, this heavily depends upon this relation. So in star, put n equals 0. What do you get? When n equals 0, this becomes d by dx of j0 square plus j1 square equals right side is 2 into first n is vanishing. Why? Because n equals 0 minus 1 by x j1 square. Okay. When n equals 1, what is it? Left side become d by dx of j1 square plus j2 square equals 2 into right side become 1 by x j1 square minus when n equals 1 it is 2 by x j2 square. When n equals 2, what do you get? It is d by dx of j2 square plus j3 square equals 2 into it is 2 by x j2 square minus 3 by x j3 square and so on, etc. Okay. If we add vertically, adding these equations vertically, what do you get? Its left side becomes adding vertically, what do you get? Left side becomes d by dx of j0 square plus 2j1 square, 2j1 square plus j2 square plus j2 square, 2j2 square plus etc. All the terms other than j0 repeats twice. So it is j0 square plus 2 into j1 square plus j2 square plus j3 square plus etc. Okay, equals, come to the right side. 2 into, minus 1 by x j1 square plus 1 by x j1 square cancelling each other. Minus 2 by x j2 square plus 2 by x j2 square cancelling each other. So all the terms are cancelling and right side becomes 0. Then you can integrate on both sides. So on integration, what do you get? On integration, left side is d by dx vanishes, it is j0 square plus 2 into j1 square plus j2 square plus j3 square plus etc. equals right side integral of 0, so it is an integrating constant c. If you put in the c equals 1, then our result is obtained, that is j0 square plus 2 into j1 square plus j2 square plus j3 square plus etc. equals 1. So this is immediately followed from this relation. Okay. So now consider this relation, j0 square plus this one. So this can be rearranged as, what is j0 square here? j0 square is 1 minus 2 into j1 square plus j2 square plus j3 square plus etc. j3 square plus. So all jn square, jix or jnx, jx square either they are positive or 0. They may be greater than or equal to 0. Okay. Since jx whole square greater than or equal to 0, then here this implies j0 square which is less than or equal to 1. When all of these terms are zeros, it should be 1. Otherwise, it is less than 1. So j0 square less than or equal to 1. j0 square less than or equal to 1 means modulus of, so j0 x, modulus of j0 x less than or equal to 1. jpx be the Bessel function when p equals 0, that's an integer, then modulus of j0 x less than or equals 1. Enough? Okay. So that's an interesting one. Modulus of j0 x less than or equals 1. Again, from here, j0 square is this one. From here, extend to jn only. Jn square, 2jn square. Put this 2jn square to the left side. What do you get? Minus 2jn square become 2jn square. Equals, come to the terms, what remains there? 2jn square equals, it is 2jn square equals 1 minus j0 square, 1 minus j0 square minus 1, put this minus 2jn square to the left side, simultaneously j0 square to the right side. What remains there? 1 minus j0 square minus 2 into j1 square plus j2 square plus j3 square plus etc. plus jn minus 1 square plus jn plus 1 square plus etc. Okay. So that means jn square equals half of the term on right side. So on this jx greater than or equal jx square greater than or equal 0. So clearly you can say that modulus of or jnx square, jnx square or jn square less than or equals 1 by 2. Why? Because jx whole square greater than or equals 0. So from here we can conclude that modulus of jnx less than or equals 1 by root 2, where n equals 1, 2, 3, 4, etc. Okay. So these are the two interesting values, that is modulus of j0 x less than or equals 1 and the modulus of jnx less than or equals 1 by root 2. Okay, thank you.